All right, sorry, I just split this up into a second video. I got interrupted. So I'm going to continue where I left off. Our next postulate is known as the ruler postulate. It's basically just a common sense postulate, right? That tells us how to find the length of a segment on a number line. Well, we already did this, right? If I'm going to scroll back here, remember just a few minutes ago when we were talking about what's the length of JE? Well, intuitively, everybody knows that the length of JE is 6, right? Because you start at 1, you end at 7, so you can subtract 7 minus 1, and that tells you the difference is 6, right? And so that's basically the ruler postulate. The only additional thing about the ruler postulate is what if somebody decided to subtract 1 minus 7 and go from left to right? Now you're going small minus larger number, and so you're obviously going to end up with a negative, which is okay if you want to subtract that direction, but you just have to remember that distance has to be a positive value. There's no such thing as negative distance. So you have to take the absolute value. All right, it's probably been a while since you've heard that word. All right, so remember absolute value is those vertical bars. And so that's all this, all of this mess right here that I'm highlighting in yellow. That is all that's telling you, right? If you want to find the length of a segment on a number line, all you have to do is subtract. And if you happen to end up with a negative number, then you need to make sure you just turn it into a positive and take that absolute value. Okay, but again, most of us intuitively do that anyway. Okay, so we're just going to look at a couple examples over here. It says find AB, and please don't forget when it just says, I'm going to highlight it. Notice there's no bar, so when you see that, it says find the length of segment AB, right? All of that, all these words are in this one little notation right here, right? So when you see find AB, that means it wants you to find the length of segment AB, okay? All right, and it says if A is at negative 33 and B is at 15. Now you don't have to do this, but I always, if a diagram is not drawn for me, I always draw a diagram, right? So A is way over here at negative 33 and point B is on the number line but way over here at positive 15. Now, you don't have to show me work for this, right? This is basic arithmetic. If you can do it in your head, you can type it in your calculator really quick. But essentially, I am going to just write the ruler postulate down just so we can get practice with it. You don't have to show me this work, but I'm going to take the highest number minus the lowest number, because the ruler postulate says that we can do that to figure out how wide the entire span is. And of course the double negative will change into a positive, and so we'll end up getting 48. So AB is 48 units long. You can of course subtract the other way, right, and do negative 33 minus 15, but you'll get negative 48, in which case you just need to take the absolute value since distance can't be negative. Okay, easy enough, you're just subtracting. Now, obviously, most of our questions aren't going to stay that basic. So if you look at example number 2 here, again, I'm going to kind of draw a picture and label it as I read. So on this one, it's telling us A is at negative 10 and B is at positive 15. And they want to know what number on this number line is 3/5 of the way from B to A. All right, so there's a couple things I want to caution you about in this problem. The first one is, please make sure you pay attention to the direction they want you to travel. It does not say from A to B, so we are not automatically always going from left to right. This one wants us to start at B and wants us to move 3/5 of the way towards A. And they want to know, where does that land? That's kind of a little, let me not go quite so far. That seems a little lengthy. Right? So if I were to stop here 3/5 of the way, what is that number? Now there are a lot of different ways that your brain can think about this, right? So I'm going to go over just a couple of them really quick. The first one is, of course, to figure out the entire length of AB, because I clearly don't want to go all the way from B to A, but I can see very clearly using the ruler postulate that the length of AB is 25 units, right? So if I went from B all the way to A, then I would have gone 25 units, but I don't want to go that far. I only want to go 3/5 of the distance. So I can just multiply, right? The word of means to multiply 3/5 of 25. And I can just figure out what that is. So 3/5 of 25, and you can do that in your head or you can use a calculator. that's 15, right? So that's telling me that I don't want to move the entire 25 units. I only want to move 15 units from B to A. Well, if B starts at 15 and I move 15 units to the left, then where am I ending up? Well, clearly that would be 0. Right? And that is my answer, right? If I move 3/5 of the way from B to A, I'm going to land on 0. Now, some students, they don't like, their brain doesn't really think of it this way. So I will tell you that we're never going to give you gross numbers here, right? So the fact that 25 is a multiple of 5, you'll notice that we're breaking it into fifths. We're always going to do that on these questions, right? I'm not going to tell you to, ask you what number is 3/7 of the way, right? Because 25 doesn't split up into sevenths. So the fact that we're always pretty friendly with our numbers means that if you want to, because I know this is 25, I can split that into fifths, right? Because that's what my denominator is. Well, obviously 25 into fifths is 5 units. So what I can do then, I'm going to erase all this, not make a big mess, is I can divide this into, sorry, those are not very even segments. I apologize. Oh, I don't really want to erase all of that. Sorry, if I was better I should have drawn my green arrow a little nicer. Let's pretend that all of these are equal segments, right? So, sorry, I just don't want to erase it all. That's 1/5, that's 1/5, that's 1/5, that's 1/5, and that's 1/5, right? So I divided my 25 into fifths, right? So clearly everyone is 5. So this would be -5, and then of course that's 0. This would be 5, 10, 15, right? I'm counting by 5s. So some people would rather divide this whole segment into fifths and then know, oh, I'm only going 3/5 of the way. So 1/5, 2/5, 3/5. So I'm landing at 0. So just another way to think about it. You can practice kind of answering various questions. For example, what if I wanted to move 4/5 of the way from A to B? Well, then I'm paying attention, so I'm starting at A, 1, 2, 3, 4/5. So I would land at 10, right? So I can ask various questions, 1/5, 2/5, 3/5, etc. But I can also say from A to B or from B to A, right? So you just want to make sure that you're paying very close attention to that, okay? All right, I'm sorry. I think I totally went overkill on that question. All right, the very last thing we're learning today, I'm super excited about this because it's our very first postulate that actually allows us to do, algebra, right, and solve for X and answer some questions, okay? This is called the segment addition postulate, and we're going to use it a lot here in these first couple of units. So basically up here is our criteria, right? If we have 3 points, it could be more, it doesn't have to be 3, but if we have points that are all collinear, then 1 or more points have to be between the other 2. So in this picture, I clearly have point B that lies between A and C, and they're all collinear with one another. Well, what you'll notice is B is clearly dividing the entire segment into 2 different pieces. So I've got 1 piece over here and 2 pieces over here. Now those pieces are not the same length necessarily. They could be if they wanted to be. But what I do know is that no matter what, because all these points are collinear, that if I know the length of AB, I can add it to the length of BC, and together those two, that sum has to equal the length of AC. Again, it's a postulate, right? So this is like common sense, right? Because we all know that if we take part of something and we add another part of that something, it's going to equal the whole thing, right? The whole thing is the sum of its parts, as the saying goes, right? So we add up all the parts and that has to equal the whole thing. Now we want to make sure the parts are not overlapping and that the parts that we're adding do form the whole thing, right? So there are some situations that you want to be careful of, but overall it's a pretty easy postulate, okay? So we're just going to go answer some questions here. These first two, I don't really expect you to show me any work. You can set up an algebra equation if you want to, but you don't have to because it's just basic arithmetic. Now, when we get down here, you'll start noticing how we start seeing some x's showing up in our expressions. That is when you need to start writing down your algebra equations and showing me your work, right? Because I actually want to see what equation you're setting up based on the segment addition postulate. I want to see that relationship, and then I want to see your solving process, okay? It's been a minute since you guys have had to solve equations, so we're going to have to get in that groove again. Okay, so on this one, it wants us to find the length of xz, right? That's what that's saying. So again, you can just do it in your head. I'm just going to write some stuff down though. Clearly, xz is the whole thing, which must be a sum of its two parts, right? Using that segment addition postulate. So I can just add those together, and clearly we are going to get 21. Again, you don't have to show work for that. You can just add that in your head. Okay, the next one says find the length of CD. So it's asking us for this length right here. Now this one has a lot of overlapping parts and we don't need everything, right? So the cool thing about this question is they gave us the BC is 20 and they also told us down here that BD is 36, right? So using that segment addition postulate, I know the whole thing is 20 plus whatever the length of CD is. So CD is acting as my variable, right? Because that's my unknown length. So of course I can just subtract the 20 to figure out that there's 16 units left for the length of CD. Right? So again, you don't have to show me work there. That's basic arithmetic that you could just do in your head if you'd like. All right, but then we get to example number 3. Right, and so we kind of have, now we're introducing x's, so we have a little bit more complicated of a problem, right? So we know this part plus this part has to equal the whole thing, right? So we can just set that algebra equation up. So 2x plus 3 plus 3x minus 1 equals the whole thing. Or of course you can put the 27 on the left and all the other stuff on the right. It doesn't matter which side you put your stuff on. So I have part plus part equals whole. Remember from solving algebra equations, we need to combine like terms if they're on the same side of the equal sign. So that's going to give us 5x plus 2 when we add our constants. If you want to go ahead and start here and you want to combine like terms in your head, I'm totally fine with that as well. Okay, you could take that shortcut if you'd like. And now I'm down to a basic two-step algebra equation, right? I would like to see your solving process, even if you can do it in your head. It's not going to hurt us to get some equation solving practice under our belts and writing down our steps. Okay, so we get x equals 5. Now notice it didn't say find x, it said find xy. So clearly we need to take our x and we need to plug it into this expression to see what we get for the actual length of xy, right? Which again, you can do that in your head. I'm gonna write it all out just so I don't lose anybody, but you can totally do that in your head. So clearly I get 10 plus 3, so I'm gonna get 13. Now I'm gonna stop right here because I don't wanna jump the gun and just be like, oh, okay, so the answer is 13. I'm gonna throw that in over here, right? I want to check my answer and I want to make doubly sure that it is in fact 13 and I didn't make some silly math mistake somewhere along the way. Okay, and it's super important. It takes less than 5 seconds to check your answers. So not only am I going to plug it into xy, but I'm also going to plug that 5. And again, you don't have to write it out. You can just do it in your head. I'm going to plug that x equals 5 into 3x minus 1. So that I can tell that YZ is 14 units long. And then I totally know that I'm correct 100% because 13 plus 14 is 27. And again, that took me less than 5 seconds just for that extra insurance that I did not make a silly algebra error somewhere along the way, right? It's going to catch my mistakes for me, okay? So you always want to make sure to check your answers, right? So check answers, right? Always. Not everything in math is checkable, right? So you totally want to take advantage wherever you can. All right, this next one, we just have a couple left. The next one is very similar to the one we just did, right? We totally have part, an expression for that part, and an expression for that part, and an expression for the whole thing. So as long as I have an expression for part, and whole, I can totally use the segment addition postulate. right? So we are going to do negative, oh, sorry, I don't want to write in highlighter there. Negative 3 plus x plus 10 equals the whole thing, which is 2x minus 1. And again, I'm going to go ahead and combine my like terms that are on the left-hand side. Now I end up with an equation, though, of course, where my x's are on different sides and my constants. So just remember basic rules of algebra, right? If you want to pick up an entire term and move it to the other side, right, you have to add or subtract it, right? You've got to do the opposite. So I'm going to take this x and I'm going to subtract it over to the right. So that's going to become just 1x. And then I'm going to take my negative 1 and I'm going to add it to the left. So I'm going to get 8 equals x. Now you might be thinking, oh man, it's been a while since I've done algebra equations. I'm not 100% sure I didn't make a silly mistake in there, but that's okay because we totally can check our answers, right? I'm going to plug that 8 in wherever I see an x. So that's going to give me a 5 here. And I obviously already know that that's 10. And then I'm going to get 2 times 8, which is 16, minus 1, which gives me 15. And do all those numbers mesh? Yeah, because 5 plus 10 is going to give me the whole length of 15. So I know that I did this correctly. So when it asks me for the whole length of TV, I know that that is 15. All right, again, 5 seconds to check your work. Totally worth it. All right, our very last question. This stumps people sometimes, but remember, your job in a geometry class, you are a clue finder, right? If you get stumped on a problem, it's probably because you have not found the clue, right? So what a lot of students do when they see this, they get so used to the segment addition postulate. So they're like, awesome, I've got part plus part. So they'll start writing this down and adding the two segments together. And then they're like equals. And then they're like, And then some people try to do this. They're like, well, it equals PR, which is not untrue, but I can't solve this algebra equation because X is a variable and technically PR is also an unknown variable because I don't know what that whole length is. So you have an equation with two variables and you can't solve an algebra equation with two variables with only one equation. So we have a problem. I even see some students that are like, well, I don't know what that is, so I'll make it a Y. Well, again, that doesn't help you get anywhere because it's two variables in one equation and we can't solve for that, right? So that's when you're like, well, crap, I'm stuck. Like, what am I supposed to put there? And so when you start feeling that way, right, when you are like, I'm not really sure where to go from here, go back and look at your diagram and ask yourself, am I missing a clue? And I'm sure most of y'all probably saw this like 5 minutes ago when I started this problem, right? But we want to make sure we are seeing these congruency marks, right? If we have those congruency marks, then that is the clue that we need to be finding. So remember, the definition of congruent, right, is that they have the same or equal length, right? So, oh, well, if PM and MR are the same, then that means I can set their expressions equal to each other. Right? And that's up to you to see that clue, or else you'd be stuck and you wouldn't be able to solve this problem any other way. Okay, so how is this problem different? I'm just going to write you cannot use the segment addition postulate. I'm just going to abbreviate that if you're okay. Right, the only way you can use the segment addition postulate is if you have an expression for one part, an expression for the second part, and an expression for the whole thing. And we don't have that here. So we need to go back, find our clue that it's a midpoint so that we can set the two parts equally to each other. And now it's nice and easy, right? So I'm going to add my two x's over to this side. And then I'm going to add my 12 over to this side. So I get 6x equals 33. I divide by 6, and I'm going to get 5.5, right? The only answers I want are either 5.5 or 11 halves. Please do not write 5.5 like this ever. We do not use mixed numbers in high school, okay? So your answer is either 5.5 or 11 halves. And the only reason I'm accepting the 5.5 is because it's a finite terminating decimal, right? It's exactly 5.5, okay? All right, and of course I'm not done because it didn't ask me just for X, it asked me for the whole length of PR. So of course we're gonna take those answers and we're gonna plug them in. So if I do 4 times 5.5, which is 22, subtract the 12, I get 10. Right? Now, I'm not just gonna assume the other side is 10, right? Even though it should be, I'm going to check it, right? We want to make sure we check our answers, catch any silly mistakes that we might make along the way. Sorry, my pencil is so glitchy. So -2 times 5.5 is -11 plus 21. What do you know? I get 10 and 10, which of course I had to because they're congruent, which means the length of PR is 20. All right, so that is it for the day 2 notes. I know that was a lot of information, but nothing too crazy. Your homework assignment, though, has some challenging questions on it. Please remember on your homework, if a picture is not provided for you, you should be drawing one, right? It's always important to give yourself a visual aid, right, to help you set up the problem, right? So make sure you're sketching diagrams, right, if you haven't been given one in that problem. Okay, all right, we'll answer questions in class tomorrow and have fun with your homework.